This is the answer key video for the topic 7.2 practice problems on the direction of reversible reactions. Okay, so again, the whole point of equilibrium is that it is a reversible reaction. We can form products, we can form reactants, right? Again, forwards, backwards, all right? And again, when we say forwards, we mean from left to right. We mean from left to right. When we talk about reverse, we're talking about from right to left, okay? And again, even when these are products, these products become our new reactants, or these are the reactants in the reverse direction, okay? So again, getting a really good understanding of terminology here is going to help you out later in the future, all right? But equilibrium, again, the whole point of this is equilibrium is reached when the rate of the forward is the same as the rate of the reverse, okay? So again, it's that dynamic equilibrium, back and forth. All right. Now, sometimes we can see where the rates of the forward or the reverse are larger. Okay. So, for example, if we look at this here, the reactants to products has a larger error. Okay. Because what that's saying is that the rate of the forward reaction is greater than the rate of the reverse. Okay. But again, this only happens when we are not at equilibrium. Okay. When we are not at equilibrium. Okay. Now, if we have a greater forward reaction, that means there's going to be a net gain in the amount of products. Okay. So again, for example, if we start with 100 and we push 50 back over here, the products may only push 25 back. So we have ultimately gained more in the products. Okay. But on the other side, if we look and we have a rate of the reverse that is greater than the rate of the forward, right, the products are going to make more reactants than the reactants do products. Therefore, there's going to be a net gain in our reactants. Okay, and again, remember, this happens when we are not at equilibrium. Once we're at equilibrium, the amount of products and reactants that are made, okay, or the rate at which they are made stays the same. So again, we have no net change in the concentration of our reactants or our products. Okay, now, and we look at the first problem here. The reaction given is at equilibrium. Okay, but what happens to the rates of the forward and reverse if some NH3 is added at this time? Okay, so if we add more of our products, okay, if we have more of our products, the rate of the reverse direction, okay, going from this to this is going to increase because we want to reestablish our equilibrium. Okay, we want to reestablish our equilibrium. All right, so the rate of the reverse will be greater than that of the forward until we reach equilibrium. Because again, we added more of this than we were supposed to, so therefore we've got to push it back that way. Okay? Again, as always, watch the We Do problems, please and thank you. All right, now the first You Do problem. Hydrogen and iodine gas were placed in a 1 liter container and allowed to reach equilibrium at time equals 2. Okay, so we know here that this is our equilibrium. All right, now there is our reaction. We got to check, of course, is it a balanced chemical reaction? Yes. Okay, so what this is saying is one H2 reacts with one I2 to form 2 HIs. Okay, now A says complete the box for time 1 when one of the H2s has reacted. Okay, well, something we don't tell you is if one of the H2 reacts, what did it have to react with? With one of the I2s. Okay, so it had to react with one of the I2s, all right? And what did it form? 2 more HIs, or 2 HIs. Okay, so if we look at time 0, we start with 4 of each, 4 H2s and 4 of I2s, okay? Now, which is which? All right, well, this is going to be our I2 most likely based on our atomic radius. However, in this example, you don't really need to know because again, it is even, right? We start with 4, we start with 4. And again, it's a nice 1-to-1 ratio. So again, not necessarily the most important thing, all right? But when we have one of these react, we're going to take one blue and one purple and we're going to rip them apart and we're going to form an HI. Okay, so at time equals 1, you should have 3 untouched purples. Okay, you should have 3 untouched blues. Then you should have 2 blue-purple mixes. Again, standing for our HI. All right. Then at time 2, we've reached equilibrium. Okay, so what you can see here is we had one more reaction between an H2 and an I2. All right, so we have doubled the amount of HIs that are formed. Okay. B says complete the box for time 3 after we've reached equilibrium. Well, that's kind of an easy one. If we've reached equilibrium at time equals 2, time equals 3 looks exactly the same as time 2. So you could have copy and pasted this again. All right, because again, the definition of equilibrium is that the net concentrations are not changing. All right, then C says between time 1 and time 2, which reaction is favored, the forward or the reverse? Well, okay, since we made more HIs, right? We made more products. That means we favored the forward reaction. Okay? If somehow we went from this and over here at time equals 2, we made more reactants, we would have favored the reverse direction. Okay? So again, understanding what you're being asked. All right, number 2, plot the provided data on the graph. Okay, so again, right there, make your key, colors or not colors, symbols, whatever, okay? But make sure you fill in your key. All right, and then, of course, we start with 20 A's, 10 B's, and 0 C's. And again, we just follow based on the data that we're given, okay? And then it says at time 10 seconds, so we're looking right here. Which reaction is greater, the forward, reverse, or neither? Okay, so this question could actually be asked, what are we making? Are we making more products, reactants, or neither? Okay, well, since we're going downwards and our products are going upwards, okay, we're losing A and B, which are reactants, and we're gaining more C, which is products. We are favoring the products, meaning we have a greater rate in the forward direction. Okay, now at time equals 40, okay, we can see we flattened out and we've been at equilibrium. Okay, so at time equals 40, we are favoring neither direction because both are happening equally. The rate of the forward is the same as the rate of the reverse, okay, because we have no net change in any of our concentrations. Okay, then D says, at what time did we reach equilibrium? Okay, so I think this one here is where we get a little confused. Okay, equilibrium happens when we are flattened and we do not change. Okay, so equilibrium is happening here, all right? And the reason it's not happening before this is because we don't have any data that supports that this is shifted over here, okay? Doesn't matter if your graph looked flatter over here. The data that we have is that at 40 seconds and beyond, the concentration stays the same. So you can only make the assumption of what you're given. Okay, so equilibrium happens at 40 seconds. Why? Because at 40 seconds, we have the concentration, and it does not change after 40 seconds. Okay? Then the last one, E. Why is the amount of A decreasing faster than the amount of B? What can you infer about the balanced chemical equation? Okay, well, first off, we can infer that this is not balanced. A plus B does not equal C. All right, what we should be looking at is that A is used up much faster than B. That's why that slope goes down, okay? So how much faster? Well, 2 times, okay, 2 times. And how do I know that? Because if I look here, that went down by 8, while this one went down by 4. Okay, so if these were both 1 to 1, this would be a 4 and a 4, an 8 and an 8. But this is 2 times the amount of this. And if we look at it in other intervals, this one's a 4, that one's a 2. So it's going to be the same. So we are going to use 2 times more A than we do B. Okay? And if we needed to infer a little bit further, we could make the argument that C is something along the lines of 2 A's and 1 B. Okay? 2 A's and 1 B. Or again, you could say like A4 and B2, but again, they have a common denominator of 2, so it ends up being A2B. All right? And the last one here, number 3, given the equilibrium reaction. Okay, so again, 2A turns to B plus 2C. All right? Which of the following will be favored if each of the following stresses is applied to the system at equilibrium? So again, the key there is at equilibrium. Okay, at equilibrium, the rate of the forward is equal to the rate of the reverse. So if we add more A, okay, we add more here, the forward reaction is going to be favored because we need to get back to our normal. Okay, you can think about this like a teeter-totter or a seesaw, right? If I'm sitting here, if all of a sudden I add more A, and I was here at balanced, well, I need to get rid of A. I need to dump it to B, okay? Because then that will get us back to our balance, all right? On the other side, if we add more C, okay, if we add more C, okay, C's too high, we need to get it back, so we're going to dump it there. All right, back to normal. Okay, and I guess actually, technically, in this teeter-totter analogy, I should probably flip these guys. All right, because if I add more A, that should make it heavier. So apologies. Okay, we'll go like that. All right, and for my C, right, if I add more C, I'm on the product side. Okay, I'm now heavier. I need to go more back that way so that I am now balanced. Okay, then on the last one, if we start at neutral and we remove B, okay, if we remove B, that means we're going to go like this. Okay, so we need to get it back to balanced. So how do I do that? I shift or I favor my forward reaction. I'm going to dump more to the products because they just lost products. All right? So, again, I like to think about it like this. However you like to think about it is totally fine. But it's a balancing game. Okay? If I add more reactants, I need to make more products to get that back to balanced. If I add more products, I need to go in the opposite direction to make more reactants to again get back to balanced. But if I remove, right, if I remove products, okay, then I need to favor my forward to remake what I lost. What? So, of course, if you have any questions, let me know. Otherwise, thanks, guys.